Hello, everyone. Thanks for having me here today to talk to you about PhotonAssay. So I'm here to share with you the inner workings of the PhotonAssay technology and then some of the overall benefits. So let me just go to the next slide. Oh, come on. There we go. Okay. All right, so first of all, what is PhotonAssay? So it's an innovative technology designed to deliver faster, safer, and more accurate gold analyses to the mining industry. It's an environmentally friendly alternative to fire assay, both on-site and at commercial laboratories. So PhotonAssay is actually a technology that was originally designed at CSIRO back in 2001. So our CTO, James Tickner, and his team were the original pioneers of PhotonAssay, and they worked on it until it was deemed to be a commercializable product in 2017, and that's where the company Chrysos was created. So currently, we have more than 10 million samples that have been processed through the PhotonAssay unit, and at the moment, 300,000 samples are being run per month around the world, operating across 4 continents. So here's a map. Everyone seems to be showing a map today of where our PhotonAssay units are located, and you can see that they're predominantly clustering in Canada, Africa, and Australia at the moment. And these units are distributed across commercial labs as well as on-site labs that are run by laboratory companies and on-site labs being run by the mining companies. So some of our major customers include Barrick, Agnico Eagle, Goldfields, Newfound Gold, as well as exploration companies like Novo Resources and Spartan Resources. And we also have many laboratory customers, including ALS and SGS, who is here today. So this is what a PhotonAssay unit looks like. This one is located at Intertek here in Perth, and you can see there's a second unit sitting next door to it. So we have a kiosk in the middle. This is where the operator stands and loads the samples onto the unit. So the whole unit only requires one operator, and it has a throughput of 40,000 samples per month if the sample is being run 24 hours a day, which is the case for some of our units around the world. So at the kiosk, the operator is then scanning the barcodes on the top and the side of the jar, and then getting the fill and the mass measurements using barcodes, and then placing the jar onto the in-feed belt, which is the one in the picture closest to us, where it then sits in the queue waiting to go into the PhotonAssay unit. Once it goes inside, it's then analysed, the samples analysed, and then they come out on the outfeed belt, where the operator can then move them on for further analyses down the line. So here on the right bottom picture is the picture of the in-feed belt with all the jars lined up, and at the top you can see that there's both white and black jars. The white jars are unknown samples, so these are customer samples, and then the black lid jars are the CRMs that are going through for monitoring the PhotonAssay unit, so our QA/QC samples. There are also blue lidded jars that go through, and those are our mining customers' CRMs. So the unit has no visibility to the fact that those blue ones are CRMs. They go through as unknown samples. The reason they're blue is so that the lab can identify which CRMs are there for us versus which CRMs are there for the mining company. So from a PhotonAssay perspective, it's been designed to be a safe, efficient, and easy to operate unit. So it's a fully automated sample handling system. So the operator loads and unloads of samples from outside of the unit. And it has an electronic X-ray source, which is a really important feature from a safety perspective, because it means that if there's no power being fed into the unit, there's no radiation being produced by the unit. Additionally, the radiation levels and interlocks are all in compliance with state and national regulations. So one of the great things about it being fully automated is that it means that there's less staffing requirements for the laboratory company operating the unit, but also it reduces the opportunity for human error. Right, because they're just unloading and loading samples, so there's not a lot of opportunity for sample swaps to occur during the process. Since we've been talking about ISO accreditation, so PhotonAssay is located on some sites where they have ISO accreditation for the PhotonAssay process, and Chrysos helps companies who are looking to get PhotonAssay ISO accredited because they do need to provide information about the technology to the governing bodies. Additionally, we are involved in compliance reporting for JORC NI 43-101 and SEC. Sorry, I want to do the slide first. Cool. So let's go through how it works, right? So we've got our sample prep that has occurred. So either that's crushed or a pulverized sample. The material has then been placed in a PhotonAssay jar, which holds 500 grams of material. The lid's then placed on and the operator then scans it onto the PhotonAssay conveyor belt, where it then enters the unit. Once it goes into the unit, it is bombarded with high energy X-rays for 15 seconds. These X-rays sit at 8.5 MeV, and the reason we're using such high energy X-rays is because we're actually activating the gold atoms and the gold nucleus within the sample. The X-rays are penetrating the entire sample, so we're activating all of the gold atoms that are inside that jar. The jar is then moved very quickly by a robot into the detector station, where there's a detector above and below the PhotonAssay sample. And this is then counting all the gamma rays that are coming from those gold nuclei, right? Because the energy is boosting its energy level. It doesn't like to be there. It's unstable. It drops back down and it releases gamma rays. And the gamma ray we're measuring is 279 keV. So we capture all of those gamma rays, and that's then how the software determines the gold concentration for those jars. For gold analysis, it actually goes through this process twice. So it goes activation, detection, activation, detection. The reason we do this twice is to increase the statistical precision on the measurement, right? So if you've got a high grade sample, there's lots of gold, lots of information coming through the detectors. So it's very easy to get a very high, accurate and precise result. For low grade samples, you've got a much lower concentration of gold. So we send it through the unit twice. So we've got twice as much information for every single sample. And that then enables us to get our high quality results at those low grades. So for PhotonAssay, the detection limit is 10 ppb. And that second run is part of the reason why we can get that detection limit down. So it's competitive with fire assay. Once it's gone through twice, the sample exits the unit and the data is then reported to the LIMS system for the mining company or lab. Before it's reported, it actually goes through an automated QA/QC process. So the unit goes through, and for a batch of samples, which say is 100 samples, it'll go through and check all of the CRMs that are included in that batch and do its own internal QA/QC process on those samples to check that everything's working as it should be before reporting it to the LIMS system. So it's going to be really helpful for a lab company or a mining company, because it means that you don't necessarily need a human-led QA/QC team quality controlling the data, because it's already had that process done automatically. So one of the big benefits of PhotonAssay is that it's intrinsically insensitive to material type and independent of particle size. So because we're looking at the gold atoms, it's not concerned about how big those gold atoms are, whether they're millimeter size or nanoparticles. It's not concerned about what the gold is encased in, whether that's sulfides or carbons. The X-rays are penetrating through the jar and it's activating all of those gold atoms irrespective of how they're presented to the unit. So that's really powerful. It means that we can analyze wet samples, right? They don't need to be dried. Typically, we dry the samples because we crush them, but they don't need to be crushed. We crush them or pulverize them to decrease the sampling error, right? To make sure that our sample is representative of the bulk material and it actually serves the purpose that it needs to, right? Making sure that a sample is fit for purpose for the mining company. Additionally, like high sulfide materials can be quite challenging for fire assay. You might have to reduce the sample size down from 50 grams to 30 grams. That once again increases your sampling error. It's not concerned whether or not a material is a sulfide. It's not concerned if a material is a carbon. And it can also analyze solutions, which can be very helpful and useful. The main benefits of this is that it can simplify the laboratory process, right? It simplifies the setup because all of these samples can be run through the same unit on site or at a commercial lab. I'm going to go back to the slide now. So PhotonAssay offers a fast alternative to traditional methods like fire assay. So if we quickly just go through the fire assay process, which I'm sure many of you are familiar with, but if you're not, I'll just run through it. It's typically a 9-step process. So first of all, you get your sample it enters the lab, it needs to be dried, then needs to be crushed and pulverized. You then take your 50-gram sample and you then take it to the fire assayers. Here they prepare the sample by adding a litharge, which is typically like a fluxing agent, which is typically lead oxide. And then they mix that up and put it into a furnace. When it's in the furnace, it is then melted down. And then once it comes out of the furnace, it needs to be cooled. The slag, which is the rock material that's not useful, needs to be removed from the sample. And then you're left with a lead button. The lead button that contains the gold then goes into another furnace. And then it comes out as a gold and silver prill, which is then dissolved in concentrated acid and then sent through a spectroscopy instrument such as an ICP or an AAS. This process typically takes 3 to 4 hours and involves several skilled labourers and multiple human touch points, which increases the chance of human error or potential contamination for your samples. In comparison for PhotonAssay, we're looking at a simple 3-step process. The first one is drying the sample. The second one is crushing the sample and getting it put into a PhotonAssay jar. And there are smart crushers that can simplify that process as well, putting the sample straight into the PhotonAssay jar. And then it's put onto the conveyor belt. And from that point, it's a completely automated process, and the operator then just removes it from the outfeed belt post-analysis. So PhotonAssay is offering a simple sample prep and a simple automated measurement process, offering less opportunity for human error. So there are also several environmental benefits to PhotonAssay. Because it's not changing the material anyway, you're measuring the sample in situ, right? There's no chemically intensive process to extract the element of interest from the rock that it's hosted within, right? For fire assay, you need lead, typically. I mean, there are other ways of doing it, but lead is predominantly the method of choice for fire assay. And this is needed in the process, which means that the fire assayers have a risk of, lead poisoning in their blood. It has happened in the past. There was a case last year in Kalgoorlie where a fire assayer had 3 times the safe limit of lead in his blood. And it has the risk to cause serious health issues. It's not something that we should ignore. Fire assay was a necessary process for grade control and things because there wasn't an alternative. Once you've got some alternatives, you need to start really looking at the environmental impacts of the method that you're using. Additionally, the lead and the hazardous waste has to be disposed of correctly. The materials and the chemicals also have to be stored and monitored within the lab. The disposal of these byproducts is a real concern for labs and mining companies nowadays, and the concern is only going to grow as everyone becomes more environmentally conscious. So just a quick summary, comparing PhotonAssay to fire assay. Yep. So PhotonAssay takes 2 to 3 minutes, whereas PhotonAssay takes 3 to 4 hours for a batch of samples. So PhotonAssay is a faster, more informed opportunity for more informed decision making. You're also reducing the sample prep. Typically, our customers crush their material rather than pulverizing, and that also reduces the amount of time it takes before you get your results from a laboratory. And it's also non-destructive, so that material can then be used further down the process for other uses, right? You can send it off for a multi-element analysis, or you can actually reanalyze it if you are concerned about some kind of sample swaps that could have occurred earlier in the process. We're looking at a much larger sample size. This is one of the biggest benefits for mining companies, right? You're looking at 500 grams of crushed material rather than a 50-gram aliquot of fire assay, of pulverized material for fire assay. So this can really reduce sampling error and can improve the representativity of their results for their mining purposes. We also have a series of environmental benefits. So the CO2, you've got lower CO2 per sample, there's no hazardous waste, and you also have a reduction in the energy per sample. This can be a great benefit for the labs, right? It's better for them to be not producing as much CO2 and to have lower energy requirements for the same number of samples. And it's also automated. So this is going to decrease human error, decrease the opportunity of contamination, and also reduce staffing and training costs. Because the operators, although they are trained, it's a relatively simple job, right? You can have someone in half a day, they're trained up on how to use PhotonAssay. So even if you have high turnover at a lab, that's not going to be a concern for PhotonAssay. So PhotonAssay is used across the entire mining value chain. So we do have predominantly mining customers. So we're looking at grade control, production samples. There are quite a few companies using us for exploration and also for products. So as it was talked about before by Graham, I believe, around making sure things are fit for purpose, right? PhotonAssay has the ability to be fit for purpose for quite a few different ranges of the mining value chain, not just exploration or grade control or production. So here is a list of the PhotonAssay services available. So I've talked a lot about gold. And here we've got the gold standard service, which is the 2 cycles, but we also have the ability to do a high precision service, which means it goes through more times, reducing that detection limit. This is particularly useful for samples like met tail samples, for example. Yeah, met tail samples, for example, because it means that they can get that lower detection limit, and that can really help increase the precision for those measurements. Additionally, we can measure silver. Now, it works out quite well that silver is also activated at 8.5 MeV, which means that we can measure both elements at the same time. They are slightly different, which is why we have a gold optimized and a silver optimized service, but great that you can get both at the same time. We can also measure copper, but unfortunately that isn't activated at 8.5. That's activated at 12 MeV, so a higher energy service. So for our customers that analyze gold, silver, and copper, they'll send the sample through the unit once for gold, silver, and they'll send it through a second time for copper. So it is a second analysis, but it's very simple for everyone involved. There's no risk of contamination or issues because it's just going through the same unit twice. We also have the moisture service and the solution service available, moisture for all elements and solution for gold at this point in time. So since I'm presenting to a lab audience, I would like to go through the QA/QC processes so that you guys can understand kind of what's happening under the hood. So from an instrument QA/QC perspective, the PhotonAssay software is completing low-level checks and monitoring various systems throughout the whole process from start of operation and during sample analysis. So this is things like checking the Linac energy, that the detectors are working as they should, that the safety systems and the automated systems are all continually doing their job. We also put CRMs through the black lid jars that we talked about before, and these are consistently tracking data quality and instrument precision. So these black lidded jars, they have a certified grade and an SD band associated with them, so that then at the end of each batch, the unit then checks that CRM against its certified grade to make sure that it's performing as it would expect within the batch. We then have customer blind CRMs, which are the blue lids. They go through for customers through their independent QA/QC checks, but the unit has no idea what they are. They just go through as unknown samples, so there's no risk of, PhotonAssay cross-checking itself. So one of the things that Chrysos is really passionate about is providing good quality and high quality data to our customers. So we actually have a 24/7 QA/QC support team that are operating at all times to make sure that any data that does flag or fail the QA/QC that's automatically done, there's someone there within 15 minutes, half an hour to be checking that data and making sure it gets reported as quickly as possible to the mining customers. As we know, for some batches, the turnaround time expected for them is a few hours. So making sure that those get prioritized is really important to us. And so we make sure that we have that team available at all times to provide that quick quality data to our customers. Cool. So another important question that mining and exploration companies need to answer is whether the analysis method they're using is giving them accurate and precise data, right? Is it fit for purpose? And that is a question that I'm not sure everyone actually knows the answer to, what the definition of fit for purpose is. We can talk about, we'll talk about accuracy and precision, but because fire assay has been around for so long, it's just the accepted method. And unless something is going wrong with your reconciliation or with your mine, then typically it's deemed to be fit for purpose. So for PhotonAssay, because you're changing things up, you're using a new technique that has a bigger sample mass and also potentially a different particle size, it's important to understand whether or not you're getting the data quality that is required for your purposes. So when we talk about accuracy, so here we've got PhotonAssay results against certified fire assay results. And you can see that when it comes to accuracy, everything is performing as you would expect. PhotonAssay lines up with fire assay across the entire grade range for CRMs. But CRMs are well-known homogeneous materials and don't reflect the realities of a mine site or a deposit. So the question then comes down to precision, right? How well does your sample represent the larger bulk sample that it's there to represent? So here I've got an example of a moderately heterogeneous gold deposit. And so what we did during this test is that we sent a load of samples through PhotonAssay, we pulverized it, put it through into a PhotonAssay jar, ran it through the unit, and then we sent the entire sample off of fire assay. So 350 grams in a PhotonAssay jar, you get 7 fire assay aliquots of data. And you can see when you compare the PhotonAssay with the fire assay to extinction results in the grey, that everything lines up quite nicely. There's less than 5% variation between the two results, which is great. It shows that PhotonAssay is an accurate method. But the more interesting aspect of this is when you compare a single fire assay aliquot against the PhotonAssay result. Because when you're in the realities of the mining world, you're getting 1 fire assay aliquot of data. And you can see in the red that the difference between the first fire assay aliquot and the fire assay to extinction, there's a big difference, which is indicating that from a precision perspective, it's not so much that there's a problem here, but it's that PhotonAssay is going to be giving you a more representative answer around your individual samples. So this is another way of looking at the same thing. It's a graph of a heterogeneous ore deposit. So here we're looking at total measurement error, and this is a reflection of sampling error and instrument precision. Typically, sampling error is the biggest driver, and sampling error is driven by mass and particle size, 2 factors that we're playing with when we're looking at fire assay and PhotonAssay. So what you can see here is that the total measurement error for fire assay sits between 50 and 60%, right? So there's a big sampling error component to measuring any individual sample with fire assay, which is what we saw in the previous slide. In comparison for PhotonAssay, you're looking at a much lower sampling error, which is great. The really interesting thing is that whether or not you measure that sample crushed or pulverized makes almost no difference to your results. And that's great for a company with this kind of deposit because it means they don't need to pulverize their sample, which means they're reducing cost, they're increasing the turnaround time, and they're also reducing the opportunity for sample contamination. So this here is a disseminated gold deposit, right? So the gold's much more homogeneously distributed throughout the samples naturally. And that's reflected in the lower total measurement error that you're seeing. So fire assay, you're looking at 10 to 15%. PhotonAssay 2 mil crush product, you're looking at 8%. And then for 75 micron, you're looking at 5%. So there is an improvement if you pulverize your samples, right? But it's not huge. Yeah, the difference between 5% or 8% is probably not going to make or break our reconciliation for a mine. And so the benefit of not having to pulverize once again is going to be a bigger benefit for a mining company. So it's one thing to show that you're getting better quality data with PhotonAssay. The other thing is the fact that you can also get this data faster. So here is the typical this is for an on-site lab, right? So you're going to automatically get much better turnaround times because you've got one customer, it's really close, so everything's, as optimal as it can be. For fire assay, they were looking at 1 to 2 days for production, for exploration, 7 to 21 days, and then for MET shift composites, you're looking at 12 hours. When the mine site then transitioned over to PhotonAssay, we're looking at less than 24 hours for production and exploration. Big win for exploration teams because typically they get pushed to the back of the queue. The queue is not long anymore, right? All the samples are going through quickly because your sample prep's reduced, you're only crushing the material, and the turnaround time for the actual measurement is also much faster. The met shift composite samples was down to 7 hours, with the ability to reduce that down to less than 2 hours through the use of the moisture service. Because they can bring it from site, they filter press it, put it into a PhotonAssay jar, send it straight through the unit, which means that there's the opportunity there for the metallurgists to get almost a quasi real-time result and help them understand and potentially mitigate any issues that they're seeing in the met plant as it's running. So I just want to finish off. I don't know how I'm doing with time, but I just want to finish off by going through a case study or a use case for PhotonAssay. So this is a document that was released by Nova Resources around using PhotonAssay technology. So they recently boosted their drilling results by reassaying larger samples for their WA Ningari North project by using PhotonAssay. So when they got their initial results, the geologists had identified visible gold in the samples. They then got their fire assay results for those materials, and it came back lower than what they were expecting, right? Quite a lot of variability in the results and lower grade considering they'd identified visible gold. So management made the decision to send a larger 2 kilo bulk sample off for PhotonAssay. So they did 4 PhotonAssay crush jars to represent each sample. And from that, the average of the pot grades actually increased their overall gold concentration quite significantly, because the coarse gold and the visible gold isn't necessarily going to get captured in the fire assay aliquot. And there's there's a lot of issues with contamination and everything when it comes to coarse gold for fire assay. So for this particular deposit, it's really beneficial for them because it means that it actually has the ability to positively impact their project, right? The project's viability is going to be dictated by the grades that they're getting, especially for an exploration company. So this is a great example of how the larger sample mass has actually improved the company's, I wouldn't say outlook, because they're a big company, but definitely for that particular project. So I just want to leave you with the fact that PhotonAssay, we don't like to look at it as a replacement for traditional methods, just from an environmental or a safety aspect. We like to look at it as an optimization tool, right? The ability to improve the quality of data that gold mining companies are getting and enabling those companies to make better decisions and improve mine site efficiencies. Thank you.